Hey guys, we are going to be doing some things. Some of this is going to be old stuff, but a little spin to some of this. Okay, so today, my young grasshoppers, we are going to be simplifying radicals and, more importantly, using the Pythagorean Theorem. Make sure you have a piece of paper ready to go. You are going to end up taking a picture, a selfie with your computer holding your notes so that I can see that you are actually taking them. Okay. Um, Now, we're going to start off here. Just a quick review over simplifying radicals because when we utilize the Pythagorean theorem, there are times where they use decimal form, but there's times that they use exact form. And exact form requires us to um, simplify these radicals. So simplifying the square root. Now, the decimal is easy. You just punch it in your calculator. Square root of 32. And I get 5.65685, blah, 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 blah. Okay. But it's not perfect. That is an irrational number. So if I'm utilizing this, it's helpful to have a more exact form. So this is one of the ways that you could do this. Now, in order for something to be a square root and be able to be simplified, you have to have two of the same thing. Okay. So I'm going to break this down into primes. So we have 2 times 16. Sorry, I should say square root of 2 times the square root of 16. And when I look at 16, 16 is square root of 4 and square root of 4. Well, look, I have two of these square roots of 4s. So if I have two square roots of 4, that means I have a 4 on the outside. Okay? And the 2's left over. And that would be my answer. Now, I put the second one on here because, guys, there are sometimes they're just perfect ones. Square root of 36 is 6. Okay? And that's done. Okay, the next one. Square root of 128. Remember, you're looking for pairs. Okay? Sometimes you have to go all the way down to your primes. So for this one, I have 2 square root of 2, because I know it's even. See, 128 divided by 2 is 64. Okay? The 64, I know 64 is 8 times 8. Okay? And once again, look at there. I have 2 square roots of 8. So that means I have an 8 on the outside, and I have a square root of 2 that's still left over. Anything that does not have a buddy, you could say, goes back and stays on the inside. Square root of 200. Well, there's many different ways, so I'm going to do this one a little bit differently. So you're going to see this one broken down a little bit further. Square root of 200. Well, I see it ends in a 0, so I know I can divide it by 10. Square root of 10 and square root of 20. Well, square root of 20 ends in a 0, so I know I can divide that by 10. Square root of 10, see, 20 divided by 10 is 2, so square root of 2. Okay, and I like to cross that off, as you saw. I didn't do it in the first one, but because I just want the stems left. And once again, look at that. I have 2 square roots of 10. Well, that means I can put a 10 on the outside, and I have the square root of 2 left over. Okay, now I want you to go ahead and practice this real quick. This is something from algebra. Okay, so let's go ahead and pause the video, and I want you to do these 4 problems. All right. The way I would do this one, b square root of 2, square root of 9. Square root of 9 is 3 times 3, and there are my pairs. So I have 3 square root of 2. Square root of 8 is square root of 2 times square root of 4. Square root of 4 is square root of 2 times square root of 2. And I have 1 pair of 2s there, of square roots of 2. So I have a 2 on the outside, and then this one's left over. So 2 back on the inside. 150. It'd be square root of 10, square root of 15. This would be square root of 2 and square root of 5, so I don't need the 10 anymore. 15 is 3 and 5, so I don't need the 15 anymore. And there I found a pair. So I have a pair of 5s. So it'd be 5. Now this one's a little different because you have 2 things left over. So I'd go ahead and remultiply those. 2 times 3 is 6. Okay, 72. That would be 2 and 36. 36 is 6 times 6. And I got a pair. So it'd be 6 square root of 2. Okay, so now you are going to see that just a little bit. Okay, but do understand, I wanted to make sure you guys saw this because there are times where you're going to have a multiple choice answer or something where they're going to give the exact form. And all we have is, we might just have the decimal, and we need to go ahead and look at that. So let's get to the meat of it. The Pythagorean Theorem. Okay, the sum of the squares of the legs is equal to the square of the length of the hypotenuse. Things to remember. Okay, it's a squared plus b squared equals c squared. That's a general format. A and the b are the legs of our right angle. And remember, C is always the hypotenuse. Okay, it's the side opposite your right angle. Okay, so let's go ahead and look at a few of these. Okay, go ahead and draw this one. And we are going to find our wonderful, wonderful x. Okay, so I have my formula. A squared plus b squared equals c squared. Now, big thing to make sure I recognize is which one is the hypotenuse. And it's the x. So I'm trying to find what the hypotenuse is here. And then I know that these are my a and my b. It doesn't really matter which one you make, A or B. Okay, you just have to have the 2 legs. So I have 4 squared plus 7 squared equals x squared. Well, 4 squared plus 7 squared, that's 16 plus 49 equals x squared. 16 plus 49 is 65. And then to get my answer, the opposite of squaring is the square root. Okay. And I would have the square root of 65 equals x. Now, if you wanted a decimal, which is what I typically use, square root of 65, I would round to the 100th. So I'm getting 8.062. So I'm going to round to here. I'm going to use this to tell me that's 4 or less, let it rest. So I'd say it's about 8.06. Okay. So get another one together. All right. So it's doing the same thing. Go ahead and draw this. And then we have to find what our hypotenuse is. And our hypotenuse here is the 12. So I know this is the C. And then these are the A's and the B's. Okay. So we start off a squared plus b squared equals c squared. So in the scenario I made, I'd have 8 squared plus x squared equals 12 squared. We square them. 8 squared is 64. 12 squared is 144. Need to get my x squared by itself, so I'm going to minus 64 on both sides. And x squared is 80. To undo the squared, we need the square root. So I get x equals the square root of 80. And this is one that could be simplified in exact form. So if they wanted it as a square root, okay, there are times where they would go ahead and simplify this. So let's do what we were doing before. So this would be 10 times 8, be 2 times 5. 8 is 2 times 4. And 4 is 2 times 2. So I have 1 pair of 2's, a second pair of 2's, and the 5 is left over. So this would be 4 square root of 5 if they used it in exact form. Again, guys, I prefer the decimal personally. So square root of 80, I'd have approximately 8.94. Okay, approximately. All right, what I want you guys to do is I want you to pause the video and I want you to do these two problems. All right, for this first one, there's our C. So let's make this A, this B. So I'd have 5 squared plus 8 squared equals x squared. 25 plus 64 equals x squared. So that would be 89 is x squared. Oops. Square root both sides. So 2 answers would be accepted here. I would accept the answer of the square root of 89. Okay. I would also accept the approximation, which I'm using. I would typically use this one, 9.43. It's approximately x. Second one. My hypotenuse is the 12. Okay, so I'm just going to make this A and B. So I would have x squared plus 6 squared equals 12 squared. So x squared plus 36 equals 144. Minus 36 on both sides. And I'm going to get 108. Square root both sides. I believe this one can be simplified. Let's get the approximation first. So 108, square root of 108, I'm going to get 10.39 rounded. And let me check for an approximation or for an exact answer. Okay. And 108 would be the same as 6 square root of 3 if you did it that way. Okay, again, I don't care which way you do it. I prefer the decimal because it's more straightforward. I just want to make sure that you're seeing that it can be represented in a different way. Okay, now the next part. Now this is a little trick that can be done, and these are called Pythagorean triples. Okay, be helpful to at least write down the top line. Okay. But these are all common Pythagorean triples. So some of them are based on the 3, 4, 5 right triangle. There's a 5, 12, 13 right triangle. There's the 8, 15, 17 right triangle and the 7, 24, 25 right triangle. These are special because they work without having any square roots. It's all nice numbers. Okay. And like 3, 4, 5, if I looked at that one, 3, 4, 5, if I looked at Pythagorean theorem with that, I get 3 squared plus 4 squared equals 5 squared. Well, 3 squared is 9, 4 squared is 16, 5 squared is 25. And look at that. I get 25 equals 25. It's a nice little deal. Okay. You get nice values to work with. That being said, whoa, why is that moving? Trippy. Let me get that out of here. That's messing with me. Now, what's nice about these is that it can be extended. So if 3, 4, 5 works, if I multiply these all by 2, I get 6, 8, 10. And that's also going to work. If I multiply them all by 3, 9, 12, 15, that's also going to work. Okay? So we can use that to help us quickly, if we can see which type it is, we can quickly get another answer without having to use the entire Pythagorean theorem. Now, this is me personally. At the end of the day, guys, when you see these next few problems, if you wanted to do them exactly like we did these, you can. There's nothing that says you can't. Okay. You're just going to go through that process. I'm going to show them using the Pythagorean triple. It is okay to do it just like this. No big deal at all. You're still going to arrive at the right answer. Okay. So I look at this one. Got X, we have 24, we have 26. Well, this is the 5, 12, 13. What I see is this is 12 times 2. This is 13 times 2. Well, I'm trying to figure out this one. We have a 5, 12, 13 triangle. Well, this should be the side with 5. And since we're multiplying by 2 for everything, this would be 5 times 2. So I know that X equals 10 because this is a 5, 12, 13 Pythagorean triple. Okay. Again, let's not lose sight. If you wanted to do Pythagorean theorem, x squared plus 24 squared equals 26 squared, and do it this way, you are going to get x equals 10 at the end. Okay, and I'll show you that just with this first one at least. 24 squared is 576. 26 squared is 676. I subtract 576 from both sides, and I'm going to get x squared equals 100. Square root both sides, and x equals 10. Okay. This is just the way using the Pythagorean triple is a nice way to get it without having to do all that other work. If you see it, that is. Okay. So look at this one. Well, let's see. I can divide. See, this one could be 13 times 3. This one could be 12 times 3. Well, that means I'm looking at another 5, 12, 13. There's another 5, 12, 13 Pythagorean triple. But this time we're multiplying by 3. So to find x, I'm going to have to multiply that by 3. 5 times 3 then would be 15. Okay. Now again, if that doesn't make sense, it's okay. Okay. Just do it the other way. No big deal. You're still going to arrive at the right answer. Now, here's some word problems that deal with this. Okay. And here's first one. A 20-foot ladder is placed against a building to reach a window that is 16 feet above the ground. How many feet from the building is the bottom of the ladder? Okay, so if you wanted to make sure you were able to reach that, what does this have to be? Okay, well, there's my right angle. So there's my C. Okay, so this is going to be my A. This is going to be my B. And I'm going to have x squared plus 16 squared equals 20 squared. Oops. And you know what I think? See, this is 5 times 4. This is 4 times 4. So this is a 3, 4, 5 Pythagorean triple. So I should, if I'm doing this right, I should get, I believe, 12 for that answer. But let's go ahead and check it out. 16 squared is 256. 20 squared is 400. Subtract 256 from both sides, and I'm going to get 144. Square root both sides, and I get 12. So yeah, it says a Pythagorean triple again. Okay. Now again, I hope you noticed I tend to think in this way. Okay. I think it's more straightforward. I think it's more concrete. Okay. So that's what I would lean towards. For this one, sometimes we're going to have to draw a picture. 10-foot ladder is placed against the building. The base of the ladder is 6 feet from the building. Okay. How high does the ladder reach? So let's see here. Let's just kind of draw it. The ladder's 10 feet. Okay, it's 6 feet from the building. We need to figure this part out. Okay. Well, I'm seeing it again. 5 times 2, 3 times 2. So this has to be a 3, 4, 5 right triangle times 2. So I know that x has to be 8. Okay. Again, if you wanted to do it the normal way, you could. All right. So that is the basics. And that'll get you through page 1 of your worksheet. Okay, let's go ahead and look at these next problems so that we can know exactly what type of triangle it is. Okay, so here's the deal. If they gave you a triangle, okay, they gave you the triangle, and you tested it with the Pythagorean theorem, you would know whether or not, or I should say what type of triangle that it is. Okay, so if I do this, a squared plus b squared equals c squared, okay, if they are equal to each other, okay, for instance, the 3, 4, 5 right triangle, 3 squared plus 4 squared equals 5 squared, okay, 6, oh my goodness, 9 plus 16 equals 25, yes, 25 equals 25. If they are equal, we know for sure that that is a right triangle. However, we can actually take that a little bit further. And I'm actually going to spin this around. Okay, I'm going to spin this around because we're going to end up writing it the other way anyways. Okay, we're used to writing it a squared plus b squared equals c squared. So I'm going to switch this around to be greater than c squared. Okay, now, when you are testing these triangles, okay, you always want to put the smallest 2 sides for A and B. The longest side always goes for C. But if we find out that the 2 legs, okay, this part, a squared plus b squared, is bigger than the hypotenuse squared, we automatically know it's an acute angle. Okay? Let me spin this around again. If we're doing a squared plus b squared, and we find that the 2 legs squared is smaller than the hypotenuse squared, then we know automatically it's an obtuse angle. So let's go ahead and look at a few of these types of problems. So here's the first one. Now, the first thing you always have to do is you need to figure out if it is even a possible triangle. Okay. And the way that we do that is you got to make sure your smaller 2 sides are bigger than the largest one. Okay. So I'm going to first check to make sure it's a triangle. The small side plus the next smallest one has to be bigger than the largest one. And that's the general way I try to think of it. Okay. So I'm just going to do a quick check. 9 plus 12 and 15. Well, 9 plus 12 is 21. Well, 21 is greater than 15. So I'm good. That's a triangle. Okay. Now I'm going to check what type of triangle. So let's use Pythagorean theorem. 9 squared plus 12 squared. Then I have some sign. 15 squared. So 9 squared is 81. 12 squared is 144. And 15 squared, I believe, is 225. Yep, it's 225. Okay, we add these up. 81 plus 144. Hey, that is 225. So 225 equals 225. I know that this is a right triangle because they're equal to each other. Okay. Let's look at letter B. Uh-oh. I might have a loading problem. Uh-oh. It'll be fine. Give me 1 second. Let me reload this. happened to me when I was doing my algebra lesson too. Oh, what just happened? There we go. All right, here's our next one. 10, 11, 13.